Welcome back everyone. In today's lesson, we are going to look at EtherChannel. So first, let's look at EtherChannel operation. Why do we need this EtherChannel? There are scenarios in which more bandwidth or redundancy between devices is needed than what can be provided by a single link. In these cases, multiple links could be connected between devices to increase bandwidth. However, spanning tree protocol will block redundant links to prevent switching loops. A link aggregation technology is needed that allows redundant links between devices that will not be blocked by STP. That technology is known as EtherChannel. So in a nutshell, what EtherChannel is doing is basically telling STP to look at these different links as one rather than many. How does it do that? EtherChannel is a link aggregation technology that groups multiple physical Ethernet links together into one single logical link. It is used to provide for tolerance, load sharing, increased bandwidth, and redundancy between switches, routers, and servers. EtherChannel technology makes it possible to combine the number of physical links between switches to increase the overall speed of switch-to-switch communication. In this example, these two physical links here will be grouped together logically to become one EtherChannel. EtherChannel technology was originally developed by Cisco as a LAN switch-to-switch technique of grouping several fast Ethernet and gigabit Ethernet ports into one logical channel. If you see here, these are a few physical links that are grouped together as a logical port channel. When an EtherChannel is configured, the resulting virtual interface is called a port channel. EtherChannel technology has many advantages. Most configuration tasks can be done on the EtherChannel interface instead of on each individual port, ensuring configuration consistency throughout the links. EtherChannel relies on existing switch ports. That means you don't have to upgrade your links to something faster. You don't have to buy more expensive connection to have more bandwidth. Load balancing takes place between links that are part of the same EtherChannel. EtherChannel creates an aggregation that is seen as one logical link. If you have several links, STP will look at it as redundant and it will want to prevent switching loops and it will block one or more of the links. So with EtherChannel, all physical links are active because STP sees it as only one logical link. EtherChannel provides redundancy because the overall link is seen as one logical connection. Additionally, the loss of one physical link within the channel does not create a change in the topology. There are certain implementation restrictions in implementing EtherChannel. Interface types cannot be mixed. So if you have a switch with fast Ethernet and gigabit Ethernet, these two different types of interfaces cannot be grouped together. Currently, each EtherChannel can consist of up to 8 compatibly configured Ethernet ports. The individual EtherChannel group member port configuration must be consistent on both devices. If the physical ports on one side are configured as trunks, the physical ports on the other side must also be configured as trunks within the same native VLAN. Additionally, all ports in each EtherChannel link must be configured as layer 2 ports. Each EtherChannel has a logical port channel interface. A configuration applied to the port channel interface affects all physical interfaces that are assigned to that interface. EtherChannels can be formed through negotiation using one of two protocols, Port Aggregation Protocol or PAGP, or Link Aggregation Control Protocol, LAGP. These protocols allow ports with similar characteristics to form a channel through dynamic negotiation with adjoining switches. It is also possible to configure a static or unconditional EtherChannel without PAGP or LAGP. Let's look at PAC-P operation. PAC-P is Cisco proprietary. It is created to aid in the automatic creation of EtherChannel links. When an EtherChannel link is configured using PAC-P, PAC-P packets are sent between EtherChannel capable ports to negotiate the forming of a channel. When PAC-P identifies matched Ethernet links, it groups the links into an EtherChannel. The EtherChannel is then added to the spanning tree as a single port. When enabled, PAC-P also manages the EtherChannel. PAC-P packets are sent every 30 seconds, and it checks for configuration consistency and manages link additions and failures between two switches. It ensures that when an EtherChannel is created, all ports have the same type of configuration. In EtherChannel, it is mandatory that all ports have the same speed, duplex setting, and VLAN information. Any port modification after the creation of the channel also changes all other channel ports. You can look at PAC-P operation like you are creating a group. You find people who have the similar interest in you, and you have all of these boxes that you check, and if they are all aligned, then they can be in your group, and you can work together as one group. PAC-P helps create the EtherChannel link by detecting the configuration of each side and ensuring that links are compatible so that the EtherChannel link can be enabled when needed. PAC-P modes include on. This mode forces the interface to channel without PAC-P. Interfaces configured in the on mode do not exchange PAC-P packets. Then we have PAC-P desirable. This mode places an interface in an active negotiating state, in which the interface initiates negotiations with other interfaces by sending PAC-P packets. PAC-P Auto is a mode where it places an interface in a passive negotiating state in which the interface responds to PAC-P packets that it receives but does not initiate PAC-P negotiation. So you have on, which is like compulsory in a channel without negotiation and no exchange of PAC-P packets. You have desirable, a mode with desires to be in a channel and starts negotiating with its neighbors. And you have auto, which is a passive negotiating. It will keep quiet until someone asks them to join a channel. The modes must be compatible on each side. If one side is configured to be auto mode, it is placed in a passive state, waiting for the other side to initiate the EtherChannel negotiation. If the other side is also set to auto, negotiation never starts and the EtherChannel does not form. If all modes are disabled by using the no command, or if no mode is configured, then EtherChannel is disabled. The on mode manually places the interface in an EtherChannel without any negotiation. It works only if the other side is also set to on. If the other side is set to negotiate parameters through PAC-P, no EtherChannels form because the side that is set to on mode does not negotiate. So there are certain mode settings example that will lead to channel establishment. For example, we have two switches here, S1 and S2. If the mode in S1 is on and the mode in S2 is on, a channel can be established. If the mode in S1 is on and the mode in S2 is desirable or auto, no channel is established because there is no packet exchange. There is no negotiation because on does not negotiate. If S1 is desirable and S2 is also desirable, channel can be established. If S1 mode is desirable and S2 is auto, channel can be established. Same goes if S1 is auto and S2 is desirable, channels can be established. If both are auto, the channel cannot be established because both are now passive. They are just waiting for packets to start negotiation. So if both are passive, nobody is going to start the negotiation, the channel cannot be established. LAC-P is another protocol that we are going to look at. LAC-P is a part of the IEEE specification that allows several physical ports to be bundled to form a single logical channel. LAC-P allows the switch to negotiate an automatic bundle by sending LAC-P packets to the other switch. It performs a function similar to PAC-P with Cisco EtherChannel. Because LAC-P is an IEEE standard, it can be used to facilitate EtherChannels in multi-vendor environments. On Cisco devices, both protocols, PAC-P and LAC-P, are supported. LAC-P provides the same negotiation benefits as PAC-P. LAC-P helps create the EtherChannel link by detecting the configuration of each side and making sure that they are compatible so that the EtherChannel link can be enabled when needed. The modes on LAC-P are on. This mode forces the interface to channel without LAC-P. Interfaces configured in the on mode do not exchange LAC-P packets. Then we have LAC-P active mode, which places a port in an active negotiating state, and in this state, the port initiates negotiations with the other ports by sending LAC-P packets. LAC-P passive is a mode that places a port in a passive negotiating state. In this state, the port responds to LAC-P packets that it receives, but does not initiate LAC-P negotiation. This is very similar to PAC-P, except for the fact that the names of the mode are different. So again, we have a table to see the combination that would result in channel establishment. If both ends of the switches are on, channel is established. If one is on and the other one is either active or passive, channel is not established, as again, no negotiation is done, so it cannot establish. If both are active, or one is active and the other one is passive, then the channel can be established. If both are passive, waiting for the other to say hello and come join me in this channel, no channel is established. Let's look at how to configure EtherChannel. So the following guidelines and restrictions are useful for configuring EtherChannel. EtherChannel support. All Ethernet interfaces must support EtherChannel with no requirement that interfaces be physically contiguous. Speed and duplex settings must be the same. VLAN setting must also match, and if it is set to be a trunk, the other side must be a trunk as well. Range of VLANs. If one side of the trunk is set to allow VLANs 10, 20, and 30, the other side must also set to allow the same range of VLANs. If it doesn't match, no channel will be established. So let's look at this example. Okay, we have two switches here, S1, S2. The speed is the same. It is both full duplex, and the VLAN they are in are also the same. These settings will ensure that either channel can be formed. If these settings must be changed, configure them in the port channel interface configuration mode. Any configuration that is applied to the port channel interface also affects individual interfaces. However, configurations that are applied to individual interfaces do not affect the port channel interface. Therefore, making configuration changes to an interface that is part of an EtherChannel link may cause compatibility issues. If we take an analogy of a discussion group or a society, if you want to make changes and you say that in the AGM or the annual general meeting, then everybody would know and changes can be applied. But if you only say to one member, that member knows, but the other members do not know, so there is an incompatibility. If configuration settings do not match, either channel cannot form. So in this case, the speed is the same, but S1 is running on half duplex, while S2 is running on full duplex. So we have incompatibility here, and the either channel cannot be formed. So let's look at some configuration example for LAC-P. This configuration creates either channel with LAC-P and configures trunking. So first we have to specify the interfaces that compose the either channel group. You want to create the group and which are the interfaces that will be the member of the group. After we do that, we have to create the port channel interface, and then we have to change layer 2 settings. So let's look at this example. S1 has 2 links connected to S2, and we want to group these two together into one Ether channel. Interface range fast Ethernet 0, 1 to 2, meaning that both these are put into that range. For both of the interfaces within that range, they will be put under channel group 1, and the mode is active. Once you do that, it will create a port channel interface called port channel 1. This one here is the channel ID. Now we need to go and change the layer 2 settings. So interface port channel 1. So for everything in port channel 1, the mode is trunk and the allowed VLAN is 1, 2, and 20. So once you do this, it has configured for both fast Ethernet 01 and fast Ethernet 02. Let's look at how to verify and troubleshoot either channel. Common issues with either channel configuration is that lack of compatibility. All interfaces within an either channel must have the same configuration of speed, duplex mode, native and allowed VLANs on trunks, and access VLAN on access ports. Ensuring these configurations will significantly reduce network problems related to the either channel. So start from the beginning. When you configure, make sure all of this align and are correct and are compatible. Common Ethernet channel issues include assigned ports in the Ether channel are not part of the same VLAN, or they are not configured as trunks. Trunking was configured on some ports that make up the Ether channel, but not all of them. The allowed range of VLAN is not the same. Or the dynamic negotiation options PAC-P and LAC-P are not compatibly configured on both ends of the Ether channel. So if you want to verify what you have configured, these are some of the commands that you can use. You can use the show interface port channel that will display the general status of the port channel interface, the show either channel summary that displays one line of information per port channel, the show either channel port channel displays information about a specific port channel interface, and the show interface either channel command provide information about the role of a physical member interface of the either channel. Let's look at a few examples. Here, we are using this topology. So show interfaces port channel 1. You will see that the port channel is up, the line protocol is up, and you can verify the interface status. Show either channel summary, it will show you what is going on, and we can see here that the number of channel groups in use is 1 because we only have 1. The number of aggregators is 1. So if you see here, it tells you that the group name is 1. The port channel right now is SU, S meaning layer 2, U means in use. The protocol being used is LAC-P, and the ports within that channel is port 01 and also 02, which both of the ports are bundled in port channel. With the command show either channel port channel, it displays port channel information. So we have group 1, and then we can see the protocol for group 1 is LAC-P, and then the ports in the port channel includes port 01, which is active, and port 02, which is also active. Show interfaces F01 either channel displays role of a particular interface in the either channel, and in this case, it's interface fast Ethernet 01. So you can see that the interface here is up. You have local information. The flags are SA. The device is sending slow LAC PDUs, which is sending LAC-P packets. And then A means the device is in active mode. When we are troubleshooting either channels, we must make sure that the interfaces within either channel have the same speed, same duplex mode, same native and allowed VLANs on trunk, and are assigned to the same VLAN. So let's look at an example. In the figure, interfaces fast Ethernet 01 and 02 on switch 1 and S2 are connected with an Ether channel. However, the Ether channel is not operational. What happened? So the first step towards troubleshooting is to view the EtherChannel summary information. The output shows us that the EtherChannel is down. Next, we view the port channel configuration, show run begin interface port channel, and we see that there are incompatible PAC-P modes configured on S1 and S2. We have information about port channel 1. Interface fast Ethernet 01 on S1 is in trunk and the mode is on. Interface fast Ethernet 02 in S1 is also a trunk and the EtherChannel mode is on. In S2, we see that interface fast Ethernet 01 is a trunk, but the mode is desirable. And interface fast Ethernet 02 is also a trunk, but the mode is desirable. As we have looked previously, if one end is on and the other one is desirable, no negotiation packet is sent, so channels cannot be established. So what we have to do here is correct the misconfiguration. So to correct the issue, the PAC-P mode on the EtherChannel is changed to desirable. We saw just now that S2 has desirable on both of the interfaces and S1 has on both of the interfaces. So here we change the interfaces on S1 to desirable. Now, one thing that we have to take care of here is that EtherChannel and STP must interoperate. So for this reason, the order in which EtherChannel related commands are entered is important. That is why you have to first delete it and then do a new one, rather than just change it. If you try to change the configuration directly, STP errors cause the associated ports to go into blocking or error disabled state. So in this example, no interface port channel, we're deleting it, and then we are making it back again. So interface range, we have the ranges of the interfaces, channel group 1, mode desirable. Two things to make sure here. One, the channel group ID is the same, and the mode is changed accordingly. Then after that, you set for all the interfaces within the range of the channel to become mode desirable and also trunk. After we have done that, we can verify that the troubleshooting actions that we did is actually successful. Again, we use the command show EtherChannel summary and we find that it is now in use and everything is working. That was EtherChannel. We looked at basic overview of EtherChannel, we looked at operations of EtherChannel, and we looked at configurations, verification, and also troubleshooting on EtherChannel. So until the next lesson, goodbye.